Thanks for coming. I'm going to talk about the many ways to play audio on the web. And in case you want to follow along, the slides are available on bit.li/adc-2019, but I will show you the link later again, so no need to rush. So what are ways to play audio on the web? This is, of course, could be a simple music player, which is just playing your favorite music, something like SoundCloud or Spotify. But it could also be something like a step sequencer, which plays an accurate loop, and it allows you to schedule something on a grid. And it might quantize your user input to make sure it's aligned on the grid and sounds nicely. And that could be controllable by a MIDI device. And in that case, it looks like it's made for the launchpad. And it could also be a synthesizer, which creates the sounds directly in the browser. And all of that is possible today. And hopefully, by the end of the talk, you have an idea which APIs you should use for that and how that all can be made. And this should be especially useful if your prior exposure to those APIs looked somehow like this, that you coded something in Faust or another language, and then at some point you just hit the export button and export it for the web, and then you got some files, and you always wondered what those files are actually doing. And hopefully by the end of the talk you will have an idea what those files are actually doing. So yeah, my name is Christoph, and I'm from Berlin. I'm self-employed. I have a little company called Media Codings, and I build multimedia applications, and therefore I'm very interested in new and modern standards for the web, and that's why I'm also part of the audio community group, which is a group of the W3C, which discusses new and upcoming standards. And if you want to reach out to me, you can find me as Chris Guttandin. The name is very unusual, but of course also unique, so that's my Twitter handle, and you can find me almost anywhere under that name. So what's the best way to play audio on the web? This is, of course, a provoking question, and there's no answer to it, at least no answer which will fit on a slide, despite that. And every use case is different, and we can try to categorize our applications to find the best way to implement it. And I try to come up with some categorizations. And the first one is we could have pre-recorded material, like with the simple music player example, or we could have live audio, which we need to transmit somehow. And that could be all simple playback, or it could be interactive. Because it's the web, we might have user input, which directly influences the content that we have. Or it could be another user on the other end of the world, which influences the content on another user's device. So it could be highly interactive. And we also have to consider the user's expectations. So if you build that media player from the beginning, it might be okay to have a little latency if you press play until you finally hear something. But if you build that step sequencer, it might not be nice if you press the button and you have to wait half a second until you hear a sound. So depending on the application, we also might have to use different APIs. And last but not least, the not so nice topic of web development is that we have to run our applications in a browser, and that browser limits us in terms of API support, and therefore I created a special slide for it. So these are the browsers which we have available today. It's only Chrome, Firefox, and Safari. All the others are gone, which I think is bad, but yeah. There is, of course, also Edge and Opera, but these browsers are not really own browsers anymore. They also are based on Chromium, which is the foundation layer of Chrome. So technically, they are very much the same as Chrome. And as you can see here, if you want to support Linux, Windows, or Android, you need to support Chrome or Firefox. Obviously, supporting both is better. And for macOS, you also have Safari. And for iOS, we only have Safari, which is illegal in my opinion, but no one asked me so far. So on iOS, we also have different browsers. There's Chrome and there's Firefox, but they are forced to use Safari on the inside. So it's only Safari on iOS. And these are the things which we had in the past. These are outdated today. And we had BG Sound, which was only available in the Internet Explorer. And we don't have the Internet Explorer anymore, which is good, so we don't have BG Sound as well. And then we had embed and object, which were used to enable or to embed Flash content mostly. And about 10 years ago, when Apple introduced the iPhone, they decided to not have plugins on the iPhone. And that made Flash totally irrelevant, so that's also gone, which is a good thing, again, as I think. Because now we have newer technologies like the audio element, and this is now a proper W3C specification, which means it's documented, the specification is openly available, every browser vendor has agreed to implement that, and we have that on every browser. So it's a simple HTML element, it just accepts a source file as an attribute, and this can be created as an HTML tag or also in JavaScript. It's essentially creating the same thing. And the main advantage or the main use case which it was built for is to play large files or large streams, because it's out of the box, it only downloads what's actually necessary. So if you have a file of about an hour and your user is only playing the first 5 minutes of it, the audio element will not download the full file, it will only play as much as needed. That's, of course, an advantage, but it could also be a downside. If you build something for offline support, then that's, of course, not what you want. But the audio element has also a couple of more built-in functionalities. So it comes with controls. You just have to say that you want them by specifying the attribute, and then you get a small player. That looks different in every browser. That's not standardized. But you always have a play button, a progress bar, and a little speaker icon to control the volume. And another thing which is not standardized is the codec support. So every browser likes some codecs better than others. And therefore, you have to sometimes provide multiple files. So if you want to play an OGG file, for example, that works nice in Firefox and Chrome, but in Safari it doesn't work because they have their own idea about codecs, and therefore you can specify another file and the browser will go through the list until it finds a file which it likes, and then it will play that. And the audio element is, of course, a very basic thing to play audio, and therefore it comes with an extension that's called the media source extension, and that's made for the use case of adaptive streaming. So in case you want to swap out the file while you are streaming it for one with a higher bitrate or for one with a lower bitrate, depending on the network conditions, that's what you use in that case. So it's essentially a JavaScript API, which can be swapped, which can be used to swap the source of the audio element. So instead of having a source file, you then have the media source as the source, and then it's your job to provide the data for the audio element. So it's a lot more work to do, but it's made for adaptive streaming, and HLS is, for example, a very popular adaptive streaming protocol, and there are libraries like HLS.js which make that very easy. And up to now, all those APIs were meant to play audio which already exists, but sometimes you want to play audio which doesn't exist, which has not existed before, and therefore we have something totally different, which is the Web Audio API, and that's a totally different concept. It's modeled after the Canvas API, so you have basically a blank sheet, which is the audio context, and that's, you most likely have only one per website, and that's where all the things happen. You build an audio graph in the audio context, and that audio graph consists of different audio nodes, and you get one out of the box, which is the audio destination node, and that will be the connection to the speakers. So everything which you connect to the audio destination node will be hearable in the end. And if you, for example, create an oscillator, that will play a nice beep sound, and if we then think the oscillator is too loud or not loud enough, we can add a gain node and then make it louder or reduce the volume. And that is meant to illustrate the principle of the Web Audio API, that it has a lot of different audio nodes, but they are all very small and made for a specific use case. And in order to build something more complex and more interesting with it, we have to chain them together and build a graph out of them. And as you can see here on the slide, there's this little gain rectangular that's meant to illustrate an audio param. So the gain node has an audio param, which can be controlled by a JavaScript. Or more interestingly, we can connect another node to it, like another oscillator, and build a little LFO with it. So that's the basic principle of the Web Audio API, but it provides a lot more audio nodes out of the box. It does, for example, have the audio buffer source node, which plays existing audio, but in contrast to the audio element, it has to know all the data up front, but therefore it can play it very accurately. So you can exactly say at which point in time you want it to start and want it to stop again. We have some basic filters like a bicquad filter or infinite impulse response filter. And spatialization is also built in. We have a stereo panel or a panel which allow you to position the audio in a 3D space if you develop a 3D game or virtual reality experience that might be useful. And then we have some basic effects like the delay, convolver, or wave shaper. And last but not least, a big principle of every web API is that it has to play well with the other APIs on the web. And therefore, there are some audio nodes which allow you to, for example, connect an audio element and take the output from that one and pipe it through the Web Audio API. Or you can also get the audio from an audio context and send it to a media stream, which can then be used to send it to another device. Or you can get the user's microphone via a media stream and put that in your audio context. So there are a lot of options to plug in different sources from other APIs. And the biggest advantage is that it runs on the audio thread, which is a different thread compared to the other threads which execute the mainframe JavaScript. And not sure if you've done web development, but there are many situations when the main thread gets very busy and blocks everything, which is not the case for the Web Audio API because it runs on its own thread. And the audio context and all the audio nodes which I showed you are basically proxy objects which just forward their instructions to the audio thread where they then get executed. And when something strange happens on the main thread, the audio thread doesn't care, it will just continue. And the API is almost done. It's not yet finished, but the process is nearing the end, and it's available in Chrome and Firefox and works very well. There's an implementation in Safari, but that's very outdated. And therefore, I created a tool called Standardized Audio Context, which tries to bring the Safari implementation on par. In terms of the API, is of course performance-wise not as good as the one in Firefox and Chrome, because the native implementation will always be better than the one in JavaScript, but at least it's useful in that way. And of course, there's also an extension to the Web Audio API, and in that case, that's the audio worklet. And that allows you to define custom audio nodes. Because no matter how many audio nodes there will always be the need for that one audio node which you desperately need, which is not yet in the standard. And in order to get that, you can write it on your own. And that can be done in JavaScript, but it can also be done in WebAssembly, and that makes it very attractive to people who have an existing code base and they can compile their C++ or Faust or whatever code into WebAssembly and then run it in the audio worklet. And this is very new. It's not very new, but it's relatively new. And it's only available in Chrome so far, but it will come soon in Firefox as well. And I have no idea what Apple is doing, but in general, they should support it at some point. But there's also a polyfill available, or 3 polyfills. The first 2 ones are standalone polyfills, which you can use, and the other one is, again, my standardized audio context library, which has a polyfill for that as well. And here's how you would write a very basic audio worklet. It's just a class which you need to extend. That's the audio worklet processor. It has one main function called process. It receives inputs and outputs, and you can read from the input and write to the output. So it's a very simple concept. And it will always be called with 128 samples. And this is a JavaScript example, but the WebAssembly use case is so popular that there's currently a new proposal about the the audio device client, which is abbreviated ADC. I thought that was funny, but it's basically the same. In my words, I would describe it as the audio worklet without an audio context. So it's meant to remove all the overhead of the audio context if you just want to run your WebAssembly code in a callback. So that's meant to make that more easy. And you can try it out. There's a prototype available. It's called Audio Device Client Prototype. And if you watch the slides later on your own device, you can click on that. All those underlined things are actually links. Should have mentioned that, I guess. But there are many, many more APIs. So far, I only talked about those which do actually produce sound. But in order to make a useful application which produces sound, you might need other APIs as well. And we have, for example, the Web MIDI API, which takes MIDI input or sends MIDI output. This is only in Chrome so far. We have WebRTC, which can create peer-to-peer connections to other computers. And you can send audio, video, and data over that connection. That API is fairly established. That's in every browser. Then we have the media session standard, where you can interact with the home screen on your mobile devices. So you can create a play button or a pause button if you have an application which needs that. And this is only Chrome and Firefox so far. Then there's the timing object, which allows you to synchronize different media. That's not in any browser, but it can easily be polyfilled. And then there's media capture and streams, which defines the input from the sound card or from the microphone. And that is available in every browser. Media streams recording allows you to create actual audio files inside the browser, so you can actually record files and download them or upload them to a server. And that's almost available in all browsers. Might be coming to the next version of Safari, but Chrome and Firefox have it already. And then it gets experimental. There's web codecs to transcode files from one format to another. That's only an idea so far. And then the web speech API is only in Chrome, which allows you to speak to the user and to recognize what they are saying. But in reality, it's always mix and match. So every application which you see in the wild will use many of those APIs and pick the things which they actually need. So if we take a look at the examples from the beginning, like the music player will for sure use the audio element because that's what it was made for. And if we will have hi-fi listeners, we might want to support the media source extensions to get adaptive streaming and to increase the bitrate if possible. And then if we want to run our website on mobile devices, we can use the media session standard to have like these play and pause buttons on the home screen, like every other audio application. And last but not least, we may use the Web Audio API to add some strange effects. So for example, if you remember the old Winamp days, when you paused the file, it echoed out a little. You could add that with the Web Audio API. And for the step sequencer, we would for sure use the Web Audio API, specifically the audio buffer source node to schedule short sounds. And we may also use the Web MIDI API to support MIDI input from a MIDI controller. And the same is true for the synthesizer, which may also use the audio worklet, just assuming that you have already code written in C++ or in Faust or Soul, which supports your synthesizer. You can reuse that by just porting it to the web and running it in an audio worklet. And here, I hope I made you curious about the web, and the next time you think about a project, you actually try it out and build something for the web. And since this is a very open process, you can, whenever you come across something which you think is not the way it should be, you can file an issue in GitHub, for example. Each of those specifications has a GitHub repository, and it's basically like with any other open source project. If you don't agree with it, you can file an issue. And if there's an existing issue, you can comment on it. And then there's the audio community group, which has a monthly meeting. So all you have to do is to sign up for the group, and then you get invitations and can join the call. It's very informal. There's a Slack channel where, it's a good place to ask questions if you have some. And last but not least, there's the Web Audio Conference, which is a conference like this in 2 weeks in Trondheim, all about those topics which I just talked about. And with that, I'd like to thank you for your attention.
Thank you, Christoph. We have time for 2 free questions. So, anyone? Oh, over there.
Do you have experience with Web Audio API in a React Native web view or in some other web view, for example, from Flutter or?
I think that's where it's not available because it's a browser technology and React Native doesn't have a browser. But I heard that there was a workshop yesterday on how to use Juice in that scenario. So that might be the better option in that case because you're running on the native environment and you don't have a browser.
I think it includes Chromium browser, but I'm not totally sure.
Electron does, for example. If you have an Electron app, you can use the Web Audio API.
Okay. Okay, thank you.
Other questions? Over there.
Can you use timestamps when you trigger sound events in web audio so that you could do like multi-track drumming or things like that?
Yeah. The audio context has monotonically increasing time. So if you start it, it has the current time and that will increase forever until it runs out of bytes. So you can use that to trigger, to schedule the sounds. And if you have any questions afterwards, you can always ask me. Find me online or just find me here at the conference.
Last one.
Thank you. What does the workflow look like for compiling my C++ application down to WebAssembly?
Sorry, I didn't get the beginning of the question.
What does the workflow look like for compiling to WebAssembly?
You have some code in C++, and then there's mscripten. It's, I think, the only, or at least the most popular one, which can compile it to WebAssembly, and then you have a WebAssembly module, and that needs to be instantiated. Then you need to transfer it to the worklet, and then it needs to run there. So that's why it's so complicated and why there is this new proposal for something which makes it a bit simpler. But it's possible.
Okay, perfect. So I think we're done with questions. Now there's the lunch break in the area for, coffee break. Thanks again, Christoph. See you for the next talk.